Hello everyone, myself V.V.Gopala Rao, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about error detection and error correction by using certain techniques called block coding. So, as far as the lesson is concerned, after completion of the lesson, so I am as a lecturer, I am actually expecting the student some kind of an outcomes from their side. So, by after completion of the lesson, student will be able to know about introduction of framing and how many types of errors are there and what are the basics of error detection and error correction, and also what is the role of redundant bits. So, very important. And there is one process we are going to see here, that is called block coding technique. So, these are the things we are going to cover in this lesson. Let us say first of all what actually the framing means and why it is required. So, the framing is a process of arranging the data in the form of bits, in the form of some fixed or in a variable length of frame. A frame is nothing but organization of bits with variable size or with a fixed size. So, you find number of bits in a frame. So, that is actually the meaning of a frame. Why actually frame is necessary? Because to send the data from the sender to the receiver in a comfortable way, so it is required to actually divide the actual data in the form of bits, so that the frames can be allowed to travel in the physical layer and they can use the characteristics of the physical layer and they can finally go to the destination station. So, here data link layer needs to pack bits into frames, because at the data link layer you definitely find the data in the form of bits. So, you cannot allow all the bits which are related to the data, you cannot put all the bits at a stretch. Better you divide the bits into certain portions, so that certain portion of bits can be filled in a block, and that block can be here referred as a frame, so that each frame is distinguishable from another, because every frame will have some a header and a tailer, so that you can identify what is the starting of the frame and what is the ending of the frame. Of course, that is the very important technique that we will see afterwards, but here understanding of frame is nothing but pack of bits, that is all. So, here the frame will travel from one station to the sender to the receiver, or sender to the destination, or source to the destination. So, the frame can travel, but so here because of the technical aspect, technical problems, or because of the network issues, the bits may be corrupted. Corrupted means they may be altered. Suppose you are sending bit 1. So, the bit may be altered as 0, or you are sending a bit called 0, it may be altered as 1. So, this is referred here as a corruption. So, whenever bit is altered with respect to the originality, so you can refer it as the corruption. So, generally because of network issues in the frame, the bits may not travel to the destination exactly what the sender sent. So, due to some reasons the bits may be altered. So, that aspect is referred here as error that is occurred here. So, error in the sense some kind of problem, some kind of disturbance, some kind of mismatch of the originality is called as an error here. So, here there are three types of errors generally which are classified as far as the framing and the bits that are there in the frame, and when they are actually in the transmission, the actual error may occur in three possibilities, in three ways. One is called as a single bit error. So, in this you see that the yellow one is nothing but the way where actually the error has taken place. Let us say there is a sender here which is going to send some frame which is filled with some zeros and ones. Let us say if you start from the right side, so there is a fourth position, there is 1 0, and that is actually once it is coming to the receiver side, then that position is altered 0 as 1 here, which is indicated with a red arrow mark. So that is why this particular change of alteration of bit value is referred here as an error or a corruption. So here that is that is actually happened with respect to a single bit. So that is why this error is referred as a single bit error. So sometimes the error may occur in two positions. So in that case it is called as the multi-bit error. So you see that here in this case of the example, this 1 is changed as 0 and this 0 is changed as 1. So there are two things that are happening here. Of course, here the sent and receiver are actually reversed here. So from the sender side, 0 is actually sent, but it is changed as 1. But similarly, in the other position, 1 is transmitted, but it is received by the receiver as 0. But either of the case, there is a error that is taken place, you can identify. But in this case, one or more, here 2 or more number of bits are actually change their positions. That is why there is a corruption that is taken place at 2 positions. That is why this is called as multi-bit error. So multi-bit error says that 2 or more bits, whenever they are altered, can be referred as multi-bit error. So now suppose the multi-bit error is there, but fortunately the bit that is altered is consecutive positions, that means they are sequential, then you can call that particular error as a burst error. So it is more or less like a multi-bit error, but the alteration is done between the sequential bits, that means the actual the bits are altered in the consecutive positions, they are actually notice it, they are changed, then it can be called as a burst error. That means you see here there is sender is sending 0 and it is received as 1 here, and the consecutive bit followed by the earlier we have seen, that is also 0 and that is also changed as 1 here. So here more than 2 bits are altered and moreover they are consecutive. So in that case it is called as a burst error. So that is why this is referred as a burst error. So that finally what I am going to say, that there are 3 types of errors we have noticed. One is single bit error, next is multi-bit error, and the third category is called a burst error. But here the important thing you have to consider is error should not be left as it is. Error should be identified first of all, and error should be corrected if possible. So if you take the error into consideration, if you leave it as it is, then the meaning of the message will be damaged. So automatically, so you carry the miscommunication, so that it reveals some the information which is not actually sent by the sender. So that what we have to do is, we have to first of all follow a procedure or a technique by which you should at least able to detect whether error is occurred or not. So that process is called as error detection process. So error detection uses the concept of redundancy, which means adding extra bits for detecting errors at the destination. So here we are very much interested to follow a procedure called error detection, by which you are interested to identify whether error is occurred or not. That's all. Whether error is occurred or not, suppose if you are going to verify, that procedure is called as error detection. For this, according to this information, we are following a technique called as a concept called as redundancy concept. We will see in the next slide, in the following slide you can understand what actually the redundancy means and why you introduce redundancy, and what do you call the redundancy bits, and what is the role of redundancy bits. These things you can able to understand in the following slide. Now you see that there is a sender here, sender node, and there is one station that is called receiver node. So now in this sender node, so this is the data which is completely of zeros and ones, which is called as a frame, and of course the frame exact data is not actually put it in the medium. So we are actually adding some more bits to the data. So data in white color, and whereas in the gray color there is a set of bits that are added to this particular data. So, that is for identifying the error is occurred or not, that is all. So, that is why these bits which are added extra to this procedure is referred as the redundancy, and the bits can be referred here as redundant bits. So, this is the way how the redundancy is actually taken into consideration in the sender side. So, why actually these redundant bits are added to this? So, these things you can understand in the following procedure. The exact role of redundant bits to identify the error is occurred or not. So, suppose if you see the medium is actually occupying with this complete pattern, then it is actually coming to this receiver side, let us imagine like that. So, the redundancy bits and the data are collectively reached to the destination. So, here at the receiver node there is a checking point that is noticed here. This is a checking point. So, here what actually been checked here is whether the data to be considered or not. That means, when do you consider the data? When there is no error that is occurred. Suppose if you are confident about that factor, then you can allow the data to consider. So, when do you reject the data? Whenever you feel that the data is corrupted in the transaction, or whenever error is occurred, you should not take the data into consideration because it is useless data. So, we have to reject the data. So, that is taken into consideration here. That is why this particular checking point is a very important point by which you can able to decide finally whether to accept the data or reject the data. So, for this case, the redundant bits are helping us to get an idea whether to say error is occurred or not in this complete procedure. So, that is why redundant bits are playing a very important role, and this process is called as redundancy process. And of course, there are many techniques by using redundancy concept, and generally they are referred as coding techniques, and but in all the cases redundancy is playing a very important role, by which you can able to at least identify error is occurred or not. So, in that in the coding there is first operation that you can identify, that is called block coding. Remember that this is for error detection. To know about error detection and error correction concepts, but of course, first of all you should understand whether error is occurred or not, then only you can go for the error correction. So, that is why the first step you are going to follow is whether error is occurred or not, that you want to know that factor. So, that is why error detection should be done first of all. So, how this can be considered, how this can be identified. So, let us start from the sender side. Let us say this is the sender node. We are here. From this, the data is there width of k bits, because we are in the framing concept, because we have to talk about bits only, because data will be in the form of bits. So, there are certain bits which are actually formed as a data word. We will see in the example, you can have a clarity about what actually the data word is. So, data we are not directly sending to the receiver side. Along with the data word, there should be some extra bits that should be generated. So, this generator is playing a very important role to generate extra bits based on the data word. The procedure that is designated to the generator, it will operate, and based on that it is going to generate a certain number of bits which will be added to the data word, and combinedly the data bits plus the redundant bits clubbed together is forming a new word, and that word is called as a code word. So, data word is now turned into code word by adding extra bits. So, those extra bits can be called as redundant bits. So, now that code word is transmitted to the receiver using some unreliable transmission medium. So, because it is unreliable transmission medium, there is a possibility of getting an error in the overall transmission. So, that is why I am particularly pointing out that it is an unreliable transmission. So, that the code word is received by the receiver with n number of bits. Why it is called n number of bits? This n is nothing but k plus r. N is nothing but k plus r. what is actually k? K is nothing but the bits that are existing in the data word, and r is the number of bits that are generated by the generator that are actually added to the data bits. So, that is the actual code word which is comprising of n number of bits here. I hope you are clear. So, now the code word is taken into consideration by the receiver, it is received by that, and it is actually allowed for one kind of a mechanism called as a checker mechanism. Here the actual process in the checker is to identify whether any mismatch is taken place or not. That will be identified by the checker procedure. Checker procedure is going to identify whether it is matching to the predetermined or predefined words or not, code words or not, it is going to check. That we will see in the example, and once it is matching to the code word that is listed in the actual table, then it is going to say that once it is matching, then it can extract, which the checker will allow the station to exactly which is matching to the code word. So, it is actually allowing the station to receive the data. So, that is why that is called as allowing the station to receive the data. So, that is why by that the checker can able to find out what exactly the data word is by removing the redundant bits from the code word. So, you can find out the data word of k bits. Sometimes the error may occur, and automatically you may identify the error that is occurred in this particular procedure. In that case, the checker will direct the station or receiver not to extract the data. So, it is automatically going to discard the data in this particular procedure. So, this is a small flow chart which is saying about how the data word is clubbed with the redundant bits, and what is the role of a code word, and what actually the receiver is going with the code word, and how it is going to finally decide whether to allow or whether to discard the data at its end. So, now if you see that with an example here, let us assume that the data word is actually 0 1, 2 bits are there. Here k is equal to 2 bits are there. So, but n is word, that is called a code word, but n is more than the data word length, because data word is of 2 bits. So, code word should not be 2 bits, code word should be more than that, because redundant bits will be added to the data word, so that it will become code word. So, that let us imagine that the code word that is actually taken into consideration is 0 1 1. That means one more bit is added at the rightmost position, which is 1. So, like this, these are the data words which are expected by the sender to send in the due course. So, sometimes it may send 0 0, sometimes it may send 0 1, sometimes it may send 1 0 or 1 1, whatever it is. So, these are the possibilities of the data words which are actually expected by the sender to send. So, similarly, for each and every data word, the respective code word is predetermined and predefined, and it should not be altered, which is unique, you can call. So, whenever the data word is sent to be sent is 0 0, it has to send the data word as triple zeros. Whenever it is interested to send 0 1, it has to carry it out by 0 1 1. Like that, it is a fixed notation which is actually been understandable by the sender and the receiver in the course of communication. So, in this case of the error detection, how this procedure of block coding is helping us to identify whether the error is occurred or not. For that, you refer this particular example and its the cases, you can understand yes, this block coding is somewhat comfortable to at least identify whether error is occurred or not. So, how it is possible? Let us say 0 1 is sent with the code word 0 1 1. But fortunately, the receiver received it as 0 1 1 only. So, no problem, because we sent 0 1 and we received 0 1 1 as a code word at the actual receiver area, because 0 1 1 is not the data, in that redundant bit is also available. So, already there is a understanding between the sender and receiver, the rightmost bit is to be considered as a redundant bit. So, it will automatically discard that and it will take the other portion as the data portion. So, automatically it is going to reflect the data as 0 1, which is exactly right. So, now suppose This is not the all the cases. Sometimes the data may be corrupted, or the bit may be altered. Suppose 011 is actually sent, and the receiver received it as 111, let us say. So then immediately the receiver will check this particular received word in the actual in the set of code words which are actually available at the receiver also. These are the code words available at the receiver. So immediately after getting the receiving the series, so it is going to check in the code word pattern, but this triple one is not at all there in the code words. Immediately it will understand that there is an error in the transaction. So it does not know where actually it is happened, but it at least identifies error is taken into consideration, error is occurred. So that is because the bit is altered, the rightmost bit is altered as okay. So we actually sent 0 1 1, but of course the leftmost bit 0 is altered as 1 here. So that is why the actual receiver is able to understand error is occurred. So that is the only factor we are actually expecting in this procedure. Suppose another case, if you consider 011 is sent by the sender and it is received as a 000, but fortunately once it is actually scanned in the code word list of code words which are in the table, but unfortunately it is matching to one code word. So in the previous step what I mentioned is that this particular procedure will tell you that at least the error is occurred or not, but this is not all the cases. Sometimes because this 000 is existing in the code words pattern, so you feel that it is a correct word and you simply remove the rightmost bit 0 and you can consider 00 as the data, so which is a wrong impression. So that is why this block coding is useful to certain cases only. This is useful to identify the error is occurred or not, that is all. You cannot understand where the error is occurred here, you cannot identify here, but at least you identify whether error is occurred not in certain cases. So that is why you cannot rely on this procedure completely, only with some limitations you can able to follow this procedure. So that is the actual meaning of this particular error detection, which is based on block coding. So now the block coding sometimes can be also be useful for error correction. So how it is possible? So similarly in the case of sender and receiver, there is an encoder processor. So this is an encoder block you can call. Encoder means which is going to convert the original into a different format. So that is why this is called as an encoder processor. So here the data is referred as a data word, and the generator, you know that as far as the previous step is considered, generator is a process of generating extra bits which are called redundant bits, and these two are clubbed and forming a code word, and that is actually transmitted in the unreliable transmission. The code word is received by the receiver, and the checker is going to check whether it is correct or not, whether it is matching to the code words list that is existing at the receiver area or not. It is going to check that, and once it is matching, then it is saying that the data is correct, and it is going to take the data word extracting from the actual code word that is there. So this is a very important procedure by which you can able to at least notice some correction is possible. There you can do some kind of correction also in this case of block coding technique meant for error correction. How it is possible? Let us consider that. So there is again a data word and code word block we are identifying here. Let us say that the 01 is sent, let 01 sent as 01011. This is the code word matching to 01. Once the sender is interested to send 01, it cannot send 01 as it is, because redundant bits are to be clubbed with 01. So in this the portion 01 is the data part and 011 is the redundant bit part. So both are combined, this is k and this is r, and this is equal to n, which is k plus r. So that is the reason why the 01 is carried to the receiver as 01011, and the received pattern is 01011. Again this is scanned in this this is scanned actually in this particular table, and fortunately this is matching to this particular the second pattern. So automatically the receiver will discard the extra bits, because already there is a definition or there is a predetermined condition. So whenever it receives the data, so the rightmost 3 bits are to be discarded, so that the remaining portion can be referred as the data, so that it is going to take 0 1 as the data. So it is correct, but it is not all the cases. Let us suppose that the data that is sent is 0 1 0 1 1, but received as 0 1 0 0 1. Once you come to this place for scanning, so it will not match. No, in the code words list there is no pattern which is matching to 0 1 0 0 1, which is other than this actual received pattern, the code word is there in the list. So it automatically notices that there is some correction that is taken place. So error is occurred in this case. How it is going to at least correct it? So that is another important thing what actually we are going to identify here. So here if you see that 0 1 0 0 1, so here in this case of 0 1 0 0 1, so you say that, so it is not actually matching to any of the code words here, all zeros are there. So now it is going to at least assume that 1 bit is corrupted. It is assuming that 1 bit is corrupted. So that 1 bit may be in which position is another important thing, it is actually to be considered here. So based on this particular procedure, so you can at least say that you consider that 1 bit is corrupted. So if you see the first, suppose if you match this first one, this 0 1 0 0 1 with this first code word, because all zeros are here, only 3 zeros are here, that means 2 bits are altered. So it is not actually the assumption that is made earlier, which is not matching to the assumption. What is our assumption? Only 1 bit is altered. So in this, if you suppose if you take this with this code word, first code word, 2 bits are to be altered. So it should not be the case of the code word of the first one. Then if you take the third one, suppose if you consider the third one, so in this actual received pattern 2 ones are here, but in this case of course 3 zeros are here, 2 zeros are available, and of course 2 ones are here, 3 ones are here, that means 2 bits are corrupted, 2 bits are actually altered. So let us say that 0 is altered as 1, and 1 is altered as 0, and 0 is altered as 1, and 0 is as it is, and 1 is as it is. That means these 3 are altered. What is our assumption? Only 1 bit is corrupted. So then what actually this should not be the case of taken into consideration. So this is also failed, the first one is failed. And coming to the fourth one, let us consider that so what actually the alteration takes place here. So we received 0 1 0 0 1, but here the pattern is 4 ones and 0. So let us say that the first 0 is altered as 1, so it is the one correction, and 1 is altered as 1 is of course 1, so there is no correction here, is right, and the third bit is 0, but here it is 1, so it is altered, and fourth bit is 0 and it is actually considered as 1, so it is also altered, and last bit is 1 and it is noticed as 0. So 4 bits are altered, 4 bits are altered, but our assumption is only 1 bit is altered, but here we are noticing 4 bits are altered. So this is also not the case of considering this code word. Then what actually the case of the second one. So let us say that you have 0 1 0 0 1 and the code word is 0 1 0 1 1. So 0 is not altered, 1 is not altered, 0 is not altered, and this 0 is altered, and this 1 is not altered. So finally what is happening is, our assumption is that only 1 bit is altered. So that is actually matching to this case. So based on that, it automatically consider this as the second code. It is more or less this is actually matching to the second code word. So it is going to take into consideration this 0 1 as the data word. So that is why this process of the block coding, in this case of the data word and the code word, so there is a chance of identifying the error that is occurred, and also you can able to, some cases you can able to correct the data, and you can able to correctly take the data word into consideration. The same thing is actually considered in this case of the code word. In the earlier example, it is only limited to certain cases, but in the second example you can able to say that sometimes the coding is the block code is useful to identify the error that is occurred, and also you can also sometimes you can correct it. So depending on the chance of the number of bits that are actually corrupted here. And of course there is one more concept I am going to consider, and that is a simple parity check code. This is another procedure where parity is playing a very important role, where the parity means, again there are two cases of parity checks we are going to discuss. One is called as even parity, other one is called as odd parity. So what actually the meaning of even parity and odd parity? So it depends on the interest that is between the sender and receiver. Sometimes you can fix to even parity, sometimes you can fix with the odd parity. So the odd parity or even parity means, so we are focusing on the number of ones and their count. Suppose you want to maintain the even number of ones before sending and after sending, then if you measure or if you count the number of ones, they should be always even number. Then this particular parity check is called as even parity check. It is not all the cases. Sometimes you can go for odd number of parity check. Then in that case the sender and receiver must and should, they have to follow the odd number of count of bits with respect to bit number 1. So that is why this particular process is called as odd parity check. So whatever it is, in the even parity check, all the number of ones between the sender and receiver should be even. Similarly, in the case of odd parity check, the number of ones the sender sent and the number of ones that the receiver received should be always odd. So that is the meaning of the parity check code here. So suppose if you see this encoder and decoder by using simple parity check, so sometimes this may be useful to identify the error whether it is occurred or not. Suppose if you take that there is a data word, as usual you know that we are in the encoder block. So there is a generator, the role of generator is to generate the parity bit. This is a parity bit, not actually redundant bit. Parity bit is different from redundant bit. The parity bit role is to add either 0 or 1, single bit, either 0 or 1 to be added at this the parity bit based on the number of ones that are existing in this the data word. Okay, suppose the data word is already having even number, let us consider we are following even number of bits. So let us say that the data word is already having even number of ones, then this generator will generate parity bit as 0. Suppose the data word is not having even number of ones, only 2 ones are there, only single 1 bit is there, then to make it as even, so the generator will raise one parity bit and that should be 1. So that is the reason the generator may go with 0 or 1 based on the existence of the even number of ones that are there in this the data word. So that is called as an even parity check. So once that is added here, then that is actually called as a code word, that is again sent to the receiver. Receiver will follow a checker process. It is going to check, where it is going to check the actual number of ones as that is discussed in the sender side. Similarly here also you have to check whether even number of ones are existing or not. Suppose in the checker side, suppose even number of ones are existing, then it is going to generate a syndrome called as 0, which is either again 0 or 1. The syndrome may be 0 or 1. So it depends on the result of checker here. Suppose the checker is noticing that already the code word is having even number of ones, which is going to generate a syndrome called 0. Suppose the checker is going to notice that the code word is having odd number of ones, then it is going to generate a syndrome that is called 1. Whenever syndrome value is 0, the decision logic block is going to accept the data word. suppose the syndrome value is 1, let us say that, then the decision logic block automatically reject or discard the data word that is actually received by the receiver. So, this is a simple procedure by which you can able to at least identify whether the error is occurred or not by following a process called as parity check. Suppose if you see that the example in the tabular format, the data is actually 1011. How many ones are here? 3. What actually I mentioned, we are going to maintain even parity check. To make it even number of ones, what actually we have to do is we have to add one more bit. So, that should be the value of the adding bit is 1, because already there are 3 ones. To make it as even, there should be one that should be generated, that bit is called as a parity bit. Here this the last one is called as a parity bit, which is generated by the generator. Why? Because to make it as even parity. I hope you are clear about why it is called as an even parity, because if you see the code word, if you count the number of ones, there are 4 ones here, which is even. So, the receiver is receiving the actual code word here. Again there are it is received actually 10111, of course fortunately which is matching to even parity. So, the syndrome that is generated at the receiver side is 0, so it is going to accept it. But this sometimes it may take you in a wrong direction. Let us go with other examples so that you can understand. So, how at what extent the simple parity check is going to useful for us. Suppose if you take the second case, so the sender sent the data code word as 10111, but the receiver received it as 10011. So, you in the checker because the number of ones is odd, so syndrome will be 1. To make it even, syndrome should be generated as 1, S0 value is 1. Already the digital logic is saying that, so whenever syndrome value is 1, so we should discard the data because corruption has taken place here. So, it is going to discard the data. So, suppose you take the third case 1011, but the code word is 10111, okay, but it is received as 10110. This is also making the checker at the receiver side to generate syndrome value as 1, so which is to be discarded, because syndrome value whenever it is 1, so it should be discarded as far as the decision logic is concerned. Then you consider the fourth case. So, 10111 is actually sent by the sender, but it is received by the receiver as 00110, or unfortunately the number of ones here are 2, that means even. So, syndrome in the checker syndrome value will be 0. So, unfortunately the decision logic allowing the receiver to accept this particular as the correct data. So, unnecessarily the data is taken into consideration, but actually unfortunately it is a wrong data. So, that is why the simple parity check is a process of checking the errors whether they are occurred or not, but to certain extent. So, that is the conclusion what I am going to say that. So, here the simple parity check code can detect an odd number of errors. Suppose during transaction, suppose the code word is changed, in even number of positions. So, then you can able to identify, you can able to you cannot identify the error occurred or not. Whenever the code word is altered at odd number of positions, that means 1 bit is altered, you can identify there is an error. Suppose 3 bits are altered, then you can understand yes, there is a error that is taken place. So, like that. So, whenever odd number of bits are altered, then only you can able to understand the error is occurred in this particular case. Whenever even number of bits are altered, then you cannot say that the error is occurred or not. So, here suppose in the case of last example, so there is 1 is altered as 0, and this 0 is as it is, and this 1 is also as it is, this 1 is also correct, and again the last one is again made it as 0. So, 2 bits are altered. So, that is what I am saying, because even number of positions of bits are altered, then you cannot detect error is occurred or not. Suppose in the previous cases, if you notice, only odd number of bits are actually altered, so that the receiver can able to understand at least error is occurred. So, that is the reason why this simple parity check code is limited to certain extent of identifying whether error is occurred or not. So, that is about today's lesson. I hope every student is able to know about actually the fundamentals of framing, and how many types of errors are there. Similarly, what are the basic error detection correction techniques, and also what is the role of redundant bits, and how the block coding technique is useful, and what are the limitations of block coding techniques is clear. Thank you very much.